Hello everybody, welcome into another lesson. So today we're going to talk about another useful property of logarithms. This is called the change of base formula. So let's say you were being asked to take something like log base 5 of 7 and find a 3 decimal approximation for it. Well, here's one problem. Calculators are only set up for one of two bases for logarithms, either log base 10, which is the common logarithm, or log base e, which is the natural logarithm. This formula enables us to convert the problem into one of those two. So, say you have some arbitrary log base c of u, where that c doesn't work out to be a format you could put it into the calculator. You can convert this into another base, log base b of u, divided by log base b of c. And that base b you pick doesn't matter, whether it's base 10, base e, what have you. So let's apply this to the log base 5 of 7. That'll work to be, we can make this log base 10 of 7 divided by log base 10 of 5. And now we have a format in which we can work with for our calculator. So let's go ahead and find that. And you get about 1.209. So the answer you should get is approximately 1.209 for your decimals. Now another way you can do this, and what we're going to do for the rest of the lesson, is we're going to use the natural log. The natural log is just base e, so you could also take the natural log of that 7 and divide it by the natural log of 5. This is another format in which your calculator can work with this. So let's go ahead here and find ourselves a decimal approximation. You get an approximately 1.209. So even though you picked a different base, you got the same decimal approximation. This proves it does not matter what base you change it to, as long as both the numerator and denominator have the same base. You can use the common logarithm or you can use the natural logarithm. The choice is yours. Now for this lesson we're going to use the natural logarithm. I just find it a tad bit easier, but it really doesn't matter. Really it's no harder, no easier than using the common log. I just tend to favor natural log more myself. But okay, so we have log base 7 of 12. So we're going to solve for log base 7 of 12. Well, using the change of base formula, we can take the natural log of 12 and divide that by the natural log of 7, and now we can get a 3 decimal place approximation. So let's go ahead and do that. You get about 1.277. So you should get about 1.277 for your 3 decimal place approximation when you do that. Alright, what about log base 3 of 16? Log base 3 of 16. You can also take the natural log of 16 and divide that by the natural log of 3. Now we have a format in which we can put this into the calculator and work with it and get ourselves a decimal approximation. You get about 2.524. So 2.524 would be the 3 decimal place approximation for this. 2.524. All right. How about log base 9 of 25? Log base 9 of 25. Well, that can be the same as, let's use the common log. I'm feeling like it. Log of 25 over log of 9. That's how it's going to look in your calculator, which we know is log base 10. So let's go ahead and find ourselves a decimal approximation. We get about 1.465. So to 3 decimal places, this would round to about 1.465 for our answer. All right, log base 2 of 5. So we have log base 2 of 5. So this can be log of 5 over log of 2. Now we got a format we can work with. Let's go ahead and input that into the calculator. You get about 2.322. So 2.322 is the approximate decimal answer you would get. 2.322 is what you should get. All right. Log base 6 of 9. So we have log base 6 of 9. Let's use the natural log. So the natural log of 9 divided by the natural log of 6, we should now be able to get ourselves a decimal approximation. Should get about 1.226. So the 3 decimal place approximation you should get is about 1.226. All right, so we have log base 3 of 17. So log base 3 of 17. Well, this is equal to, of course, let's use the natural log. So the natural log of 17 divided by the natural log of 3. And then we can find ourselves an approximation here. All right, so the ln of 17 divided by the ln of 3 gives us about 2.579. So to 3 decimal places, you get approximately 2.579 for your answer. All right, log base 5 of 32. So log base 5 of 32, that's going to equal log of 32 divided by the log of 5. So log of 32 divided by log of 5, now we can get a decimal approximation. you get about 2.153. So to 3 decimal places, the answer you should get is approximately equal to 2.153. I have 6 more. No, I'm sorry, 8 more, excuse me. How about log base 2 of 125? So I have log base 2 of 125. Well, we can make this the natural log of 125 divided by the natural log of 2, which now we have a format we can totally work with. You get about 6.966. So you get approximately 6.966 for the answer to 3 decimal places. So 6.966 is about what you should get. All right, 7 more. Log base 6 of 24. So we have log base 6 of 24. This could be the same as the natural log of 24 divided by the natural log of 6. Now we have a format we can work with to input this into the calculator. You get about 1.774. So the answer you should get would be approximately 1.774. All right, we have log base 4 of 19. So we have log base 4 of 19. So this could equal log of 19 divided by log of 4. And let's get ourselves a decimal approximation now. You get about 2.124. So the answer you should get is approximately 2.124 in the end. Five more. Log base 16 of 81. So we have log base 16 of 81. Okay, so we can make this the natural log of 81 divided by the natural log of 16, which now we should be able to get a 3 decimal place approximation. You get about 1.585. So you should get an answer of approximately 1.585. 4 more. Now this changes a bit. Log base 8 of 22 sevenths. Log base 8 of 22 sevenths. So we got a fraction, but still the same process. We can take the natural log of 22 sevenths, divide that by the natural log of 8, and come up with a 3 decimal place approximation. So let's do that real quick. you get about 0.551. So the answer you should get is approximately 0.551. Three more. Log base 9 of 5/16. So we have log base 9 of 5/16. Well, we can make this the natural log of 5/16 divided by the natural log of 9. Now we can get a decimal approximation to 3 decimal places. Alright, so let's go ahead and do this. You actually get a negative number of negative 0.529. Get about negative 0.529. That's the first negative one we've had, but yes, you get about negative 0.529 for your decimal approximation. Alright, two more. We have log base 2 of 4/15. So log base 2 of 4/15 would be the same as the natural log of 4/15 divided by the natural log of 2. And now we have it in such a way we can get a decimal approximation. Which would give you about 1.907. Negative 1.907. So you should get about negative 1.907 for your answer. And there's just one more. Log base 5 of 32/3. So we have log base 5 of 32/3. Well, we can make this the log of 32/3 divided by the log of 5. And then now we can find a 3 decimal approximation. Alright, so let's see. Log of 32/3. You get approximately 1.471. So what you should get is approximately 1.471 for the answer to 3 decimal places. So that was a very useful formula for the change of base formula, so it really doesn't matter if you change your base to base 10, which is the common logarithm, or to base e, which is the natural logarithm. But that's how you would solve problems like this. So the next lesson we are going to solve exponential equations. So I hope everyone has a great day. Take care.